Hey, test. Hello, everyone. Thank you for your attention. My name is Sergei Boiko, and today I'm going to talk about how to develop non-custodial wallets using Wallet Core SDK. So, before that, I would like to add a few words about my background. I joined Trust Wallet in March 2023 as a member of the Wallet Core team. Before that, I used to work in Komodo platform developing Atomic Desk caller library, for over than 3 years, and I have extensive experience in that field, developing non-custodial wallets. But what are the non-custodial wallets? And what's the difference between them and traditional bank applications? So traditional bank applications are centralized. Just a quick reminder, you pay high fees for international transfers, you don't have a direct access to the funds. Verification required for certain usage amounts, and KYC can be also required for opening a new bank account. But it's not the case for non-custodial wallets. They are decentralized, so you have a direct access to the funds. You pay low fees, of course, depending on the blockchain you use, and no KYC required to create a new wallet and even a batch of new wallets, and no verification required for any transfer amounts. But there are some common considerations when we're developing a crypto wallet, whether centralized or decentralized. So the main idea is to secure user funds. For traditional finance, that actually means to avoid doing some crazy things with the user funds. Like we all know the story about FTX and what it might lead to. For non-custodial wallets, it actually means to protect private keys and store them encrypted so nobody has an access to them. The next important point is to minimize application dependencies, as the more dependencies you have, the more risks you have that one of the library contains a vulnerability. But unfortunately, it's impossible to avoid using dependencies at all, so it's highly recommended to review dependencies with your security team time by time or request an external audit. I would like to talk about Wallet Core in general, present you the projects that already use it. So Trust Wallet itself, Crypto.com Frontier Wallet, and Coins Wallet developed by Coin Paprika. So pretty big names in the crypto industry, I guess. Okay, we talked about Wallet Core for a few minutes already, but we still don't know what is it and what problems it might help you to solve. Wallet Core is a low-level SDK that provides you capabilities to draft and sign transactions for over 100 blockchains. That includes transfer, staking, vote, NFT transferring, and smart contract manipulations. In addition, if you need to work with the low-level cryptographic algorithms, you can use user-friendly interface to hash and sign messages, to work with the encoding algorithms like hex, base 58, base 32, etc. The next important feature is key storage. So Wallet Core provides API to protect your private keys and to store them encrypted on the devices. For the next point, I need to let you know that Wallet Core is a C++ library. It exposes an FF5 interface, but it can be used not only by the C++ projects. This is my favorite. So Wallet Core provides high-level bindings for several languages such as Swift, Kotlin, Kotlin multi-platform, and TypeScript, so it's easy to integrate into your end-user application using your native language. We talked about the importance of having low number of the dependencies. And this rule is also applied to Wallet Core. We use low number of dependencies in C++ and Rust, and most of them are reviewed by our security team. Last but not least, Wallet Core is open source, so anyone can use it, contribute to, and justify the code and features that we provide. I would like to compare a few examples. So let's imagine we develop a JavaScript application, so multi-chain wallet in JavaScript. On the left side, as you can see, So it works, okay. As you can see, we use multiple dependencies to work with the Solana, Ethereum, Near, and Avalanche blockchains. But the list of the dependencies will be longer and longer as you integrate new blockchains. So developers team needs to find a proper library to work with the new blockchain and to figure out how to use the API of the library and how to integrate it into the existing code base. On the other hand, we have only one wallet core dependency that is completely enough to work with all of these blockchains and not limited. What are the advantages of the single dependency concept? So you have smaller bundle sizes. That means faster performance and faster load times, smaller attack surface, and fewer security risks. One API and protobuf is a standard interface that the developers need to learn only once and then apply the knowledge to integrate new blockchains. Less dependencies also means faster build times and ship faster. Probably the most informative part of my presentation today. I'm going to show you how it's easy to work with the multiple blockchains using only one wallet core dependency. So here we take a mnemonic and passphrase, create an HD wallet, and generate addresses for Ethereum and Bitcoin blockchains. So by typing only 3 lines of code, we achieve quite simple but in the same time quite complex operations. If you like challenges and typing hundreds of lines of code just to achieve the same as behind me, probably Wallet Core is not for you. But for the rest, I would like to explain one more example. How to sign an Ethereum transfer transaction using Wallet Core. We take an HD wallet that we just created and draft an Ethereum transfer transaction using a high-level interface that provided by the wallet core to work with the protobuf messages. You need to specify the destination, nonce, gas price, gas limit, transaction amount, and in the end, when you sign the transaction, you get an encoded representation that can be broadcasted to the network. And quick reminder, the same approach is applied to every blockchain supported by a wallet core. Now I would like to focus on Ethereum features in Wallet Core as we are at the Ethereum conference. So Wallet Core provides capabilities to sign messages in Ethereum specific way, so EIP 712. Of course, it works with the layer 2 solutions, including Immutable X, Optimism, Arbitrum, ZK rollups, and smart contract manipulations for transferring funds between layer 1 and layer 2. The next feature is smart wallet and account abstraction, so EIP 4337 using Altmem pool. And all of these features are possible because of the full Ethereum ABI support. It's well documented and easy to integrate to the user app. Last but not least, Wallet Core is highly extensible, so adding a new EVM-compatible chain looks like adding a new JSON entry to the registry file. I'm going to show you, but before that, one more example. The main idea is to use only one dependency, Wallet Core, for everything you need in your ETH wallet. So if you need to sign a message in Ethereum specific way and use it as an argument of the smart contract call for authentication purposes, for example, you can specify the private key and message and use Ethereum message signer for these reasons. Next, how to add a new layer 2 chain to the wallet core. So you put this JSON entry to the registry file, build bindings in C++, Swift, Kotlin, and other languages, and use it. So it's important to know that Polygon ZK rollup is an EVM-compatible chain, so we are going to use Ethereum implementation specified at the blockchain field. What can be different is the derivation path and chain ID. What about the future of Wallet Core? So it's excited. We are migrating from C++ to Rust due to the following reasons. So first of all, Rust is more secure, it's more flexible, and has a great package manager that can be that allows us to update dependencies faster and to integrate new blockchains easier. It also brings us a new cargo build system. The next feature we are working on is code generation tool. We extended by integrating, by generating bindings for multiple new programming languages such as Golang and Nim and so on. And probably the most important feature we are working on is extending bindings capabilities with the wallet kit. So, but before I will explain it, I need to let you know what can be done actually with the Wallet Core. So Wallet Core provides capabilities to work with the low-level transactions, to sign them, encode them, and work with the low-level cryptographic algorithms. But it doesn't work with the network layer. So you still need to query the balance, to estimate fees, to broadcast the transactions to the network. And this is what we get in Wallet Kit. So Wallet Kit expands the capabilities of Wallet Core by implementing network layer and integrating blockchain services. It utilizes the Wallet Core as a Kotlin multi-platform library, so for seamless integration. And Kotlin multi-platform is a technology that allows you to code a feature one time in Kotlin and then generate native code in Swift, Kotlin, and TypeScript. Yes, we are still working on it, and once it's done, it will be available public. So we are going to make it open source and publish packages for seamless integration. And it's also incredibly extensible, so implementing a new blockchain is straightforward. So you use the same API as you already used with integrating other blockchains and apply the knowledge to integrate new blockchains. The last example today. So it's completely enough to develop a multi-chain wallet by using only Wallet Core and Wallet Kit. So we create with the, we work with the addresses for Bitcoin and Ethereum and then query the balances for them. And it's easy. Thank you very much for your attention and join us on the social networks. Hope it was enjoy.
Do we have any questions? Yeah, sure.
Test. Under which license is this published?
Apache, if I'm not mistaken.
Thank you.
Do we have any more? Okay.
To be honest, I can be wrong, but yeah, let me check after the presentation.
Do you support external signers? Like, can I use a hardware wallet, for example, to sign my transaction?
Oh, sorry, could you please repeat?
Do you support external signers for signing transactions? So I can, for example, hook up an USB token to sign the transaction instead of using software.
So in Wallet Core, we doesn't support external signers, but our end-user application support like MetaMask, if I'm not mistaken, also.
Okay, thanks.
Thank you.
First time, second time? Okay, sold. Thank you, Sergey.